For years, Hollywood lighting directors have positioned images in front of their lights to create a host of visual effects. That same thing can be done inside 3ds Max using a feature called a projector map. To show you how it works, I'll be using a file named Projector Light. You can find it in the Working Files folder. The scene consists of a fountain, a little water, and a ground plane having a map applied to it to make it look like concrete. I've also added a spotlight being used for my key light and an Omni for a little fill. Let's see how the scene currently looks. We'll do that by rendering our camera view. With that viewport active, I'll click on Render Production in the top right-hand corner of the toolbar. Okay, when professional lighting directors project images through their stage lights, they have a special name for that technique, typically referring to it as adding a cutout, a gel, or a cookie. That'll many times also be called a gobo light. Gobo being short for either go between or goes before optics. Any way they decide to label it. The purpose of a gobo is to alter the effect of a light source by changing anything from its color to its design or pattern that the light casts on whatever in the scene it hits. It's a time-tested technique that's been used by lighting technicians for decades to assist in giving the illusion of something that's not actually there. The gobo could be anything from a ghosting image to a shadow created as an alternative to actually having to build something in the scene to create that shadow. A building, a light, a gate, you name it. Gobos in 3ds Max are referred to as projector lights. To set one up, you'd select the light, then in the Modify column, head under the Advanced Effects tab in the Light Settings. Let's do that. We'll close our render and select our spotlight. In the category named Projector Map, you'd then click on the None button, signaling to Max that you'd like to load something in front of the light. From the browser that opens, you'll then choose Bitmap. We'll now need to navigate over to where our image is that we'll place in front of the light. For this example, I'll head into the Chapter 12 folder of the Working Files. Let's choose the image named Sunset. Now before we load it, we'll click on the image once, then down in the lower left-hand corner, click on View. So we'll put this image in front of our spotlight, having the picture then showing through in the area of the light's cone. Let's now render and see how things look. Now, the light's fall-off is spreading too far to the sides for us to get a real good look at the map. Let's bring that range in a little. We'll close the render so we can see just what's happening as we do so inside our views. We'll open the Spotlight Parameters category in the Modify column, then take our fall-off to around 35. We can leave the hotspot value where it is. Okay, with the fall-off range now closing down some, let's render again. Okay, that's an improvement, but even better still, let's hide the fountain and we'll apply a white material to our ground. Back in the viewport, I'll select the fountain, then right-click, choosing Hide Selection. We can then head over to the Material Editor for our skin change. We'll do that by typing M on our keyboard. The white material in the lower left-hand sample slot has been named the same thing as the currently applied material to the ground, that name being ground. Because of that, we can quickly add the white skin to the scene by simply selecting the sample slot, then clicking on Put Material to Scene. Once we've done that, we can render again typing F9, the shortcut for render last. Let's also turn off the additional light that we're getting in the scene from our overhead Omni. In the viewport, we'll select our Omni light, then right-clicking on it will turn off its illumination. Rendering again, we now have a much better look at the picture that's shining through the light. Now, it's very easy to switch out the image that we have projecting through the light. We'll first, though, have to reselect our spotlight. Back under the Advanced Effects tab in the right-hand column, we'll click on the button that now reads Sunset. We're simply telling Max that we'd like to switch out the picture. From the browser, we'll again choose Bitmap. Staying in the Chapter 12 folder of our Working Files, let's this time choose the image named Face. Once we've got it loaded in place, we'll render again. Now, if you ever want to change your projector image in some way, you can do that by merely dragging it to the Material Editor, then do a little tweaking. Let's do this. We'll close the render, then reopen the material editor. Back in the Modify column, we'll locate our projector map named Face, and we'll drag it directly onto one of the clean sample slots in the editor. When we get it there, we'll reply Instance when asked to do so. This basically means that whatever changes we make to the image will reflect back into what we see in our projector light. To view our image, down in the Bitmap Parameters category, on the right-hand side, we'll click on View Image. The red bounding box we see around the picture allows us to control only what part of the picture we'll be using. Let's do this. We'll take the square handle at the top of the picture, 12 o'clock high, and we'll drop it down just above the gentleman's eyebrows. At the bottom of the picture, at 6 o'clock, we'll grab that handle, pulling it up right below his mustache. For the left and right side handles, we'll move those so they're both closer to each eye. Now before we render, to see the results, we'll have to click on the Apply button just to the left of View Image. Seeing the image in the sample slot now changing, let's render our scene once again. So that's kind of fun, but frankly not the real reason that 3ds Max offers the projector map option. A much more practical application with using projector maps is to quickly add shadows to a scene without having to add a lot of extra geometry. Let's see if we can't set something like that up. Let's close our render, then turn off the cropping option on our map. Directly above the Apply button we just turned off, you'll see the name of the map that we currently have loaded inside the light. On that button, which ends on the right-hand side with the word Face, we'll click. This tells Max that we're wanting to switch out the picture used as the projector map. This time around, let's choose the image named Tree. This picture will work ideally for casting a shadow down on our fountain. With the new tree map loaded, let's render again. So that quick and easy, we can simulate the shadow of a tree sitting just a short distance away from our fountain. Imagine how long the geometry for that tree would have taken to make, let alone the delay in render time created by the additional shadows from that tree thrown into the mix. Let's also change the shape of the area in our scene that's lit. The shape of the light's cone, in other words. Closing the render, again working on the right-hand side, under Spotlight Parameters, you'll see an option that says Circle and Rectangle. Let's change that over to Rectangle. To have our cone of light better fit the viewport, we'll adjust the fall-off on the cone to 48. Having better fit our shaded view, we'll render again. Okay, now we can reassemble our scene. Closing the render will unhide the fountain. We can do that by right-clicking on the screen and from the menu choosing Unhide All. Let's then render again. We should also get the concrete material back on our ground. Back in the material editor, we'll select the concrete skin using the command Put Material to Scene. Let's also turn the light that we're using for a little fill. That's the Omni. Selecting it back in the viewport, we'll right-click, turning the light back on. With the Omni back in action, the shadows now aren't quite as dark, creating more of a realistic effect by simulating a little bounce light. Now, if the tree image appears a little too clear and crisp, we can quickly blur that up a tad. Back in the material editor, working on the tree map, we'll change the blur offset to 0.1. Opening up a large viewing window by double-clicking on the slot, we might have blurred that out just a little bit too much. Let's see how that looks in the render. You know, I think we did. Let's take the blur offset to instead 0.03. Not quite as blurry, but still maybe a little bit too much. Let's settle in on a blur offset of 0.01. Very good. Now, if we also only wanted to use a portion of our tree map, we could crop that. Back in the material editor, in the cropping placement category, we'll again turn on Apply. With the cropping window back open, we'll take the red handle at 6 o'clock, moving it up to the bottom of the trunk of the tree. We'll then take the control handle on the far right side, moving it a little bit to the left. Let's see how that looks once rendered up. Let's finish off the project by turning on a couple of settings that I deactivated on our water material. That would be both the reflection map and refraction map due to render time. Back in the material editor, we'll select our fountain water. That'll be the slot on the top row, middle position. Down on its map branches, we'll then simply activate both the reflection branch and the refraction branch. Once we do so, we'll make one final render to see how things look. Nice outcome, and pretty painless using a projector map to simulate the shadows. What makes the Gobo Light feature in Max even more flexible is that you can even load animated clips into the light, creating a kind of TV or a movie projector effect like you see here. The movie's named Projector Movie. I've thrown it over into the Working Files folder if you'd like to take a look at it. So there you go, quite a few things that you can do with a projector map. I'm going to go ahead and save the file out as Projector Light Completed if you'd like to go in for a look.